Hey guys, and welcome back to another video on Patrick Tutors. Today we'll be talking about the 6 trigonometric functions. Let's begin first by drawing our unit circle. So, unit circle is basically a plane where you can draw out your triangle and solve for your angles. So, let's draw our triangle. So you always want to start from here, go up to this line, come down, and go over. So, in these problems, guys, remember you are always trying to solve for this angle right here. Always. This is the angle that you're always going to try and find. So your sine, well, I guess your functions are sine, cosine, and tangent. Those are the three that we will talk about first, and then we will move on to the next three. So sine, how do you solve for sine? How do you solve for cosine? How do you solve for tangent, right? So if we go back over here, off of your angle side, you have three parts. You have your opposite side from the angle, you have your hypotenuse, and you have your side that is adjacent for A. So O is opposite, H is hypotenuse. So to solve for sine, it is so, ka, toa. That's like the, I guess, words that they use to know how to make sure these problems get solved right. So, S-O-H is so it's opposite, and hypotenuse. Cosine is ka, so it's A, which is adjacent, over the H, like that. And then lastly, you have tangent, which is toa, which is opposite over adjacent. And those are how you solve the three. So that's an O. Ka, toa, just like that. Okay, so now that we have this, we're going to run through a few practice problems. So we're going to start out by trying to solve for the sine, right? So sine is opposite over the hypotenuse. So we're going to say that the hypotenuse, or the opposite side, is 4, and the hypotenuse is 16. This side we don't really need that much, so we'll just mark as x. So our sine off of the angle is our opposite side over our hypotenuse. So we would have 4 divided by 16. And this can be simplified to 8 and later down to 1/4, which would be your answer. So the sine of this would be 1/4. So that's how you would solve for that problem. Okay, now let's say that you have a new, length. You have 1 on your hypotenuse, 5 on your opposite, and 20 on your side that is adjacent. So we've already solved for sine, so now let's solve for good old cosine. So you need to take your adjacent side, just 20, over your hypotenuse, which is just 1. And that simplifies down to 20, of course, which would be your answer. So I know that seemed pretty easy, and yes, they can get a lot harder, but that's just a good intro to these. Okay, now we once again have new lengths, so we're going to try to solve for the tangent now, which is opposite over the side that is adjacent. So we have 25 for our opposite side. Remember, because it's opposite of our angle, we always want to remember that. And then we have over 100, because 100 is our side that's adjacent. So 25 over 100 simplifies down to 1/4, because 25 can go into 100 4 times. So that's how you get that. So 1/4 would be your answer for this problem. Okay, now we are going to move into the next three. So these three aren't really harder, but they aren't quite the same as your regular sine, tangent, and cosine. So we will begin. The first one is abbreviated as COT, also known as cotangent. So this one is basically A, which is your side here, adjacent, over your opposite side, which is O. So O would be here. So this is basically the exact opposite of good old tangent, which was toa, which is opposite over A. So cotangent is basically just the opposite of that. Next one is called cosecant. Cosecant is abbreviated as CSC, just like that. And what that is basically your hypotenuse over adjacent, which is the opposite of sine, which is so. So which would be opposite over hypotenuse. So H would be here, and then O would be here. So that would be cosecant. And then the last one you have would be secant. And secant is just S-E-C. And secant is hypotenuse over adjacent, just like that, which is the opposite, if you remember, of good old cosine. So the hypotenuse, as we've already said, is up here, and your adjacent, as we've already said, is down here. Okay, now let's solve for each of these. So cotangent, remember, it's adjacent, which is here, and over opposite, which is right here. So we're just going to say that up here you have 2, right? Nice and easy, 2. Here you have a 5, which is your opposite, and your adjacent, we'll say that you have a 15. So how would you solve now for the cotangent, right? Take your side that is adjacent, which is 15, and then divide that by your opposite, which is 5. And this can be simplified to 3 over 1, which is equal to simply 3. So 3 would be your answer for this problem. So that is how you solve for the cotangent. Okay, next we're going to solve for the cosecant, which is right here. So remember, it's hypotenuse, which is right here, over the opposite, which is right here. So we're going to put the side that is adjacent as 1. We're going to put the hypotenuse side, we'll put it at, we'll do 5. And then the opposite side we'll put at 25, right? So we'll take the hypotenuse, which is 5, over the opposite, which is 25. And then this can be simplified further. So 5 goes into 5 once, 5 goes into 25 5 times, so 1/5 would be your answer for the cosecant here. Okay, and the last one to solve for would be the secant, which is hypotenuse, which is here over the side that is adjacent. So we're going to put our opposite side as 4. We'll put our hypotenuse side as 9. And then we'll put our adjacent side as 81. So we'll make it a little bit harder here. So where do we go from here, right? So we take our opposite, which would be 9, over our 81. So how many times does 9 go into 9? Well, once. How many times does 9 go into 81? 9 times. So 1/9 would be your answer. Alright guys, and that is everything in this video today. Thank you so much for watching, and please hit the like and subscribe button, and comment what you want to see in further tutoring videos. Thanks so much guys. Peace.